Okay, this is question 4, paper 1. This is a functions question, and it says that the graphs of 4 functions are shown below. The graphs are labelled A, B, C, and D. The 4 functions are listed in the table beneath the graphs. So part 1 asks to match the graphs to the functions by putting the correct letter beside each one in the table. Okay, well, the way to identify is to look at the shape of the graph. That's a line, obviously, so C is a line. This is what we call a cubic, a double curve, alright? B is a single curve, it's going to be a quadratic, and this is a single curve, so it's a quadratic as well. So the linear one should be the easiest to identify because there will not be an x squared value or an x cubed value, and that's this guy here, right? So I'm going to put C in for him there. The next one then would be the double curve, because these guys aren't going to have x cubed in them because they're only a single curve. So I look for the x cubed, which is here, so it's going to be A here. Okay? Now to tell the difference between an n-shaped quadratic and a u-shaped quadratic, look at the sign in front of the x squared. If it's positive x squared, you're always going to get a u shape, so this is going to be B here. And because it's negative x squared here, you have this is going to be D, so it's a negative quadratic and n-shaped graph. Okay, so part 2 asks us to sketch the graph of the derivative of each of the functions shown in the above diagrams. So at this stage, guys, you should be able to do differentiation, okay? So I'm going to enlist the help of some extra paper here, okay? So I'm going to differentiate f of x, or in other words, I'm finding f of inverse of x. It becomes 2x minus 2. Over here, we're going to have h inverse of x is equal to 3x squared minus 3. G inverse of x is going to be 2 minus 2x, and J inverse of x, well, first of all, let's write out, so it's 3x plus 2, and J inverse of x is equal to 3. Okay? I hope we can see that clearly enough. Alright, so we'll start with what I think is the easiest one, the line. Okay, so to derive a line, that was this guy here, J of x, 3x plus 2 is 3, where the function y is equal to 3. Remember that when you find a value for J of x, you've found y. So y is equal to 3. 1, 2, 3, y is equal to 3 here. Now I apologize, I don't have a ruler, so that's roughly what your line is going to look like there. Okay, so that's the line sketched there. Okay, next ones then would be the quadratics. Alright, so the quadratics were f of x and g of x. Okay, so 2x minus 2. Now remember, guys, the minus 2 indicates where it cuts the y-axis, so it's going to cut down here for this one here. It's going to be cutting at this point here. Alright, so that's where your curve is going to be, or sorry, that's where the line will be passing through. My apologies, right? So remember that this is y is equal to this, so if 2x minus 2 is equal to y, alright, or in this case, where it's going to cut the x-axis, so we can let it, y is going to equal 0 there, so you get 2x is equal to 2, x is equal to 2 divided by 2, which is 1, so it's going to be here. Okay, and your first line is a sketch up through here. Okay. Now for the negative quadratic, which is over here, we differentiate it to get 2 minus 2x. Alright, so again I'm going to let 2 minus 2x equal 0. Now it's a positive 2 here, so it's going to cut the y-axis at the number 2. Okay, and minus 2x is going to equal minus 2, so in other words 2x is equal to 2, x is equal to 2 divided by 2, which is 1, which is here. Okay, and here's the sketch of that line there. Okay, and finally then, whenever you differentiate a cubic, you get a quadratic curve. Alright, so 3x squared, it's a positive x squared, which means it's going to be a u shape, and it's going to cut the y-axis at minus 3, so there is that part there. Okay, now you're going to get two answers for x here, so I'm just going to do it down here with a bit more space. Okay, so it's 3x squared minus 3 is equal to 0. Alright, so you're going to take out what's common. Sorry, you won't take out what's common. Bring the 3 across. You get 3x squared is equal to 3. X squared is equal to 1. Okay, so x is going to equal the square root of 1. Or sorry, plus or minus the square root of 1, because x squared, it can go in either side. So x is equal to plus or minus square root of 1. The square root of 1 is in fact just 1. Okay, so it's plus or minus 1. Here's plus 1 here, minus 1 here. So you get your nice quadratic that looks roughly like this. Okay, alright. and that is part A finished. Okay, so part B says find the equation of the tangent to the curve y is equal to f of x shown above at the point where x is equal to minus 1. Well, we're going to ultimately need the equation of the line formula, okay, which is y minus y1 is equal to the slope times x minus x1. Alright, so the first thing you're going to have to do is differentiate, because that's how you find the slope of any function, or find the slope of any quadratic function or cubic, whatever you differentiate to find the slope. Okay, so I'm going to differentiate my slope, right, which we've worked out earlier on is 2x minus 2. So f inverse of x is equal to 2x minus 2. Alright, so it's just something under. Okay, so 2x minus 2. Alright, so then now that we have an equation for the slope, we can sub in where x is equal to minus 1. So I'm going to sub in 2 bracket minus 2 is equal to minus 4. Okay, oh sorry, not minus 2, minus 1, my apologies. So 2 times minus 1 is equal to 2, minus 2 is equal to minus 4. So in this case my slope is equal to minus 4. So we're already on our way to being able to do this. The next thing though is we have to identify the point where the tangent is actually touching the curve, alright? So what we got to do is we're going to take minus 1 here and we're going to sub it into the original function. So now we're going to have f of minus 1 is going to equal, alright, so it was x squared, so it's going to be minus 1 to be squared minus 2 times bracket minus 1 minus 2. Minus 1 squared is 1 plus 2 minus 2. 3 minus 2 is 1, okay? So when x is minus 1, y is 1. So the point is going to happen approximately here. This is where our tangent is roughly going to be. Okay, sorry, I apologize, not roughly, it's exactly there at 1, 1, because when we subbed x for minus 1, or minus 1, 1, when we sub x in for minus 1, we get y is equal to 1, alright? So then we have everything we need to form the equation of the line. So it's y minus y1, which is, in this case, y is equal to 1, so it's minus 1, is equal to the slope, which is minus 4, times x minus x1, but x1 is equal to minus 1, so it's minus minus 1, so I can just change that to plus 1. So y minus 1 is equal to minus 4x, okay, minus 4x minus 4. Alright, you try and keep your x's positive, so bring everything over, you get 4x plus y, that becomes plus 4 minus 1 is equal to plus 3 is equal to 0. Alright, and that is the equation of the line, and that is question 4 at the functions question.